Next, we're going to talk about function notation. We've talked about the difference between linear functions and quadratic functions. Right now, we're going to talk about function notation. I've been writing everything in y equals mx plus b or y equals x squared notation, but function notation looks a little bit different. It looks a little bit like this. It's got these f's here, and that just stands for a function. And what this says is the function of 7 is 17. Okay, what does that mean? It means that I've got some sort of rule. We don't know if it's linear, we don't know if it's quadratic, we don't know what it is, but we have some sort of a rule that when I put 7 into it, I get back 17. So that means 7 is my input. Remember, my input is my x, and my x is my domain. And my 17 is my output. That's my y value. That's my range. So I am looking for some sort of a rule that when I put in 7, I get back 17. When I put in -1, I get back 1. When I put in 4, I get back 11. When I put in 2, I get back 7. And I want to know, what if I put in 5? What am I going to get back? Well, that could seem like a problem where you say, "Blah, I'm out. Don't feel like doing this." But you know what? It's not that hard. Think about the things we've already done. We've learned how to do term tables. Okay, so what I'm going to do is I'm going to make a term table here. Remember that my x's are what are in the parentheses, so I'm going to make a term table with those numbers. Okay, and those numbers are -1, 2, 4, 7, and I'm going to put them in order like that on a term table. And I'm going to leave all the rest of them blank. So I'm starting with -1, and I have to go up to 7. 0, 1, 2, 3, 4, 5, 6, 7. 7 goes with 17, -1 goes with 1, 4 goes with 11, and 2 goes with 7. Okay, this is what I was given. So you see a problem like that and you think, okay, I don't know what to do. Just start by making a term table. And then if there's a place where you could maybe figure out what's missing here, like for example, this goes up by 6, but if I go up by 6 here, I'll have 13. That doesn't seem to make much sense. But maybe, let's see, between 7 and 11 is 9. Maybe I can put in a 9 there. I don't know. Let's see what we can do. Oh, you know what? I made a mistake. Here was my original problem. And notice where I had f of -1 is 1. And I put it over here as 1 and 1, which is why when I tried to go, oh, that goes up by 6, that doesn't seem to make sense. It just didn't make sense to me because I made a mistake. And see, at this point, I could just restart this video and show that, oh, you know, the teachers never make mistakes. But that's silly because you know what? Teachers make mistakes too. So I'm not going to restart this video. I'm just going to tell you I made a mistake and I needed to put it right here. Okay, so now this would make sense because this seems like it's going up by 2. So let's just pretend that is still going up by 2 and see if it works. 13, 15, 17, it checked out. 5, 3, 1, it checked out. So you can actually see that this does have a pattern now of going up by 2s. Guess what? My first difference is 2. Constant rate of change is 2. So since my first difference is 2, that is our slope. Our slope is our change in our y value over the change in our x value. And when I put it into a term table, I automatically did that when I put it into a term table, it automatically made my x values, the change in my x values, be 1 because I did that on purpose. I filled in from -1 up to 7 all of the numbers so that my change was by 1. When my change in y value is 2 and my change in x value is 1, 2 divided by 1, change in y over change in x, means that my slope is 2. So what I can do here is I can take this equation and I can start filling some stuff in. We know that the slope is now 2. That was my constant first difference. So if I have y equals 2x plus b, what I'm really looking for now is my y value. I mean, my y-intercept value. Sorry, I'm looking for my y-intercept value, and that is where it's going to cross the y-axis. So if you think about this, where does something cross the y-axis? Well, let me draw something. That's crossing the y-axis at 0, 0, right? Okay, so that ordered pair is 0, 0. This is crossing the y-axis at 4, so that's over 0 up 4. This is crossing the y-axis at -2, so this is over 0 down 2. So where the line crosses the y-axis has to have an x value of 0. Otherwise, it's being shifted. If this value is a positive, it's being shifted to the right. If this x value is negative, it's being shifted to the left. The point is. So if it's at 0, it's going to lie on this line. Okay, so that's a major, major point in any kind of function. When x is 0, that's a y-intercept. Okay, so x equals 0 is the y-intercept. Okay, so if you want to do this problem algebraically, which is always going to be more accurate, you're going to want to use that equation y equals mx plus b. If you want to do it intuitively, which can get the right answer, excuse me, but you're going to have to make a term table. You're going to have to fill it in. If it doesn't have an easy pattern, maybe it's going up by decimals. Maybe it's going up by fractions. Maybe it's one of the terms is, like 797. You don't want to make a term table that big. Maybe it's a small term table. Maybe it's the terms on the y only go from like -1 to 17 like this one. But what if I said, what is f of 99? Well, you don't want to put in 99 for your x value and try to figure that out. So you can use the term table to check your work, to intuitively figure it out. But if you want to do it accurately, you're going to need to have the y equals mx plus b equation. So back to our original question here. If f of 7 is 17, if f of -1 is 1, if f of 4 is 11, and so on, what is f of 5? That means I need to know what is y when x is 5. We already know the answer. What is y when x is 5? It's 13. Okay, that's the answer to our question. We could tell that by the term table. But let's look at our equation. Okay, we already know our slope is 2, so what I'm going to do is I'm going to take one of these original ordered pairs. F of 7 is 17, that ordered pair is 7, 17. F of -1 is 1, that ordered pair is -1, 1. Like that. I'm going to just pick one of these, it doesn't really matter. I'm going to pick the one with the smaller numbers. So I'm going to put in -1 for x and +1 for y. And I'm going to put in 2 for m because we already know that our constant rate of change was 2. Our first difference was 2, so we know this is linear. All right, here we go. Y is 1, m is 2, x is -1. We're trying to find b. Y was 1, x is -1, m is 2. Solve this. 1 equals -2 plus b. Add 2 to both sides. We get 3 equals b. 3 is where it crosses the y-intercept. Where it crosses the y-intercept is where x is 0. Let's see if that's right. Look at our table. Right here. X was 0, y was 3. Our y-intercept is 3. We knew that from the table, which is always a good thing to go back to do. If you can make a table, if it's reasonable, then do it. Here's our equation. You know why it makes that so easy? Because now I could ask you f of anything and you could figure it out. My question is, what is f of 5? F of 5. Remember, that just means that my x value is 5. I put in 5 right here. 2 times 5 is 10, plus 3 is 13, so y is 13. The answer, f of 5, is 13, which we knew from our table right here. Okay? So a couple quick things is the notation uses f in parentheses, x value equals a y value. If you want to figure out if it's quadratic or linear, you start looking for your constant rate of change, your constant first difference, I mean. If your first difference is constant, it's linear. If your second difference is constant, it's quadratic. When you go to figure out what certain values are, you make your XY table, you plug in all your empty spaces, putting them in order, see if you can figure a pattern out to fill in the rest of the numbers. If you can't, then see if you can find your slope, which is your change in Y over change in X, and plug in a point and figure out your B value. Your B value is going to be when X is 0. So on your term table, or once you have an ordered pair with your slope in your equation, you can solve it and find your B value. And then you can plug in any X value to come up with any Y value. There you go.